Welcome students. This is from physics concept, that is dual nature of matter and radiation topic, part 3 session. So listen here, in this part 3 session what I am going to discuss means I am going to discuss about effect of potential on photoelectric current. So what is our topic in part 3? Effect of potential on photoelectric current. So in order to study the already in the previous class I told you about that how photoelectric current is varies with respect to intensity, and the second study was how photoelectric current will be varies with potential, and the third one how photoelectric current varies with the the frequency of the incident radiation, and the fourth one is the how photoelectric current varies with the nature of material of the emitter plate. And for today's part I am going to discuss how this potential of the collector plate is going to affect for the photoelectric current, or what is the effect of this potential on the photoelectric current. So in general, so in order to study this one we would require to recall the experimental figure what I had discussed in my previous class, but anyhow for this study I am going to draw that once again, and please go through that diagram, experimental diagram. So if you have in notebook means it is well and good, if not, so I am going to draw here, so just you can go through this, no problem. Okay, so this is window here, this is emitter plate here, and this is the collector plate, and collector is always set at positive, so it is at negative. Generally it is to observe the photoelectric effect and to have a photoelectric current in the circuit means, so it is maintained at positive potential. So it is maintained at positive potential, collector plate, and this is an emitter. Listen here, emitter is maintained at a negative potential with the help of this external energy source battery, and you know that the potential between an emitter and collector plate can be observed with the help of this voltmeter. And listen, collector is connected to the water, a positive potential, and this window, and this is a glass tube T, and this window is mainly provided in order to allow the water and ultraviolet radiation, say source radiation. Say what happens here, I am going to study here, I am going to study the variation of, I am going to study here variation of photoelectric current with respect to the potential of potential. So what potential I am going to choose means with respect to collector plate potential. So what is here very simple, I am using a source. I am using a source in the sense what I told you, a source of light. So this source of light has got intensity I and frequency F which are fixed. I am not going to vary. I am not going to vary initially. Means I am using certain fixed frequency light having some fixed frequency, means whose color will be fixed here. So if I allow to incident on the emitter plate, and initially I will maintain collector at zero potential. So initially at first case, in first case collector is at zero potential. Collector is at zero potential. So even though collector is at zero potential, so what I am observing means there is some small photoelectric current is flowing through the circuit. Though collector is at zero potential, already it is at positive potential. If I make it zero, then what happens? Though also the electrons get attracted towards this, not because of this, because of their velocity of emission, and due to that what happens, there is some small current will be there in the circuit. Due to the velocity of the electron, they move towards the collector plate, and hence there is a small current. In the second case, what I am going to do, now I am going to make, so I am going increasing collector plate potential, I make it more positive. The collector plate which was at 0 potential. Now collector plate is set at some positive potential, some positive potential. So what happens if collector plate is made at some positive potential? Very simple, which is the required condition for the observation of photoelectric effect. So you know that if collector plate is set at some positive potential, what happens? Due to the positive potential of this collector plate and due to the ejected electrons, due to the illumination of this light on the surface of this emitter plate, electrons get ejected and these electrons are definitely get attracted towards this collector plate as soon as there is a photoelectric current will be there in the circuit. So instead of at some positive potential, now I am going to increase its positive potential. As you go on increase the positive potential, you are going to observe that more and more number of electrons get attracted towards the collector plate. So what happens if more and more number of photoelectrons get attracted towards the collector plate means, so there will be a more photoelectric current, or will be the photoelectric current will be increases as we increase the positive potential on this collector plate. Why it increases? Because more number of electrons get attracted because of this positive potential. Due to the positive potential and due to the electric field, the electric current will be generated and that electric current we call as photoelectric current. So next what I am going to do in the third case. So in the third case, I am making this instead of positive potential, now I am going to make it as negative. How I am going to achieve this negative potential? This negative potential I am going to achieve very simply. So what is that? So negative potential I am going to achieve just by reversing this commutator. So just by reversing this commutator. So initially it was like this. It is connected like this. Okay, in this pattern it is connected, that is from emitter to negative terminal of the battery and collector to positive. So now I am going to reverse this potential instead of like this. So now I am going to connect like this. So what happens in the second case? Collector plate is set at, collector plate is set at. So initially going to this case. So another one point I would like to suggest here. So as a collector plate, just you recall, as a collector plate is set at some positive potential, we noticed that the photoelectric current will be more. Why photoelectric current will be more? So photoelectric current is more because more and more number of electrons will be attracting towards the collector plate. And remember, if I go on increase the positive potential, so I am go on increasing its positive potential. So is it at every step this photoelectric current is go on increases? No. So it increases initially for increasing positive potential, but at certain particular positive potential. But at a certain positive potential, given to the collector plate, we observe that what? Current becomes maximum. But at a certain positive potential, the current becomes maximum, and this current we call as saturation current. Very important definition. What is saturation current? Even though positive potential of the collector plate is increases, but the photoelectric current is initially increases. But once if you reach at a particular positive potential or a certain positive potential of the collector plate, the current becomes saturated, and that current is called as saturation current. Saturation current, the maximum photoelectric current corresponding to a certain particular positive potential of the collector plate is called saturation current. Later on I am going to show you in the graph about this saturation current. Okay, so next the third condition. Now instead of maintaining this at positive potential, now I will make it as negative potential with the help of this commutator, means I am reversing the potential. So as you reverse the potential, what happens? The electrons get repelled from this collector plate. So now I am going to make it negative means, and this I am making as positive means, even though Halbach and Lenard said that the positive plate is illuminated with ultraviolet radiation means, then also it ejects electrons. This was the Halbach and Lenard observation. Please remember, So maybe the question will arise at this condition. Sir, you are making this positive, now how can it? So just if you recall Halbach and Lenard's observation, they said that and they concluded that even the positive potential, even the metallic surface is at positive charges, though also it ejects electrons. So this is about the condition. So now third condition, I am making this collector at negative. What happens, even though if you eliminate a radiation of intensity I and F, then also there will be an emission of electron, but these electrons never get attracted towards the collector plate. Instead of attracting to the collector plate, they get repelled. Instead of attracting, they get repelled. See here, they are gone repelling. And remember, if I make it more negative, so now I am increasing negative potential on the water collector plate. Then what happens? I am gradually observing that the electron repulsion will be more. And remember, at a certain particular value of potential, so at a certain particular value of potential, and that potential I am going to call it as cutoff potential, say VO. VO means it is cutoff potential or retarding potential, we call it as cutoff retarding, we can also call it as cutoff potential, retarding potential or stopping potential. This is also an important point, stopping potential. So what is the stopping potential? So very simple, what you are observing, if you make it negative, electrons repelled. If you increase the negative potential of this collector plate, there is a maximum repulsion. So therefore, repulsion means it is stopping the electrons to reach here. So who is stopping? The negative potential. That what is that particular negative potential which stops the electron completely? Okay, completely it stops and it makes photoelectric current zero. It makes photoelectric current zero. So at VO, we have photoelectric current will be zero. Photoelectric current becomes zero. So this we call as what? This we call as what? Stopping potential or cutoff potential, or it is also called as retarding potential. So now we shall define. So what happens at retarding potential? So definition of stopping potential. So what is the definition of stopping potential? So first I am going to define about this stopping potential, and next we shall go for the graphical study of this. Okay. See, stopping potential. So what is stopping potential or cutoff potential? Stopping potential may be defined as the minimum negative potential. Yes or no? The minimum. I am increasing negative value on potential of collector plate means what? I am making more negative. Yes or no? So at a particular minimum negative potential, I am observing no electrons get attracted. Maximum repulsion is taking place, and hence photoelectric current becoming zero. Therefore, the minimum negative potential given to the collector plate at which the photoelectric current becomes zero. Photoelectric current becomes zero. Underline this point. Stopping potential may be defined as the minimum negative potential given to the collector plate at which photoelectric current becomes zero. So next, please go through this definition, which is very important for 1 mark. And even these experimental studies are also very important. So now I am going to plot the graph here. So if I plot a graph, see, this is collector plate potential, collector plate potential. So this side retarding, because negative, this negative x-axis comprises for retarding potential, retarding potential, retarding potential, retarding potential, and this photoelectric current, photoelectric current along y-axis. See, once if you look at this graph, so initially collector plate was at zero potential. Just to recall all the points what I told now. Initially collector plate was at zero potential. We are varying the potential of collector plate by that photoelectric current we are observing. But what we observed, at zero potential there is some small photoelectric current. There is some particular value of photoelectric current. There is some photoelectric current due to velocity of emission. Is it right? Due to velocity of emission, there is some small photoelectric current. So we observed that there will be a photoelectric current. There will be a photoelectric current initially. Okay, there is a photoelectric. As a collector plate potential is increased, collector plate potential means positive value. Is it right? As the potential increased, we noticed that the current is increased, and after reaching at a certain particular positive potential, current became saturate, current becomes maximum current. This is for an intensity of the light radiation I having frequency f. So say this is for intensity I. Say I1 I will use. No, I1 use. I1 is fixed intensity. For this case, I am observing that as the collector plate potential is increased, photoelectric current increased. And after reaching at a certain positive potential, the photoelectric current becoming saturate current. So that saturate current is called saturation current, saturation current. So saturated current becomes maximum. And if I make it negative, what happens? Photoelectric current is decreases, and at this particular potential VO, known as retarding potential or stopping potential, at this potential photoelectric current becomes what? Zero. At this potential photoelectric current attains zero. Very important. Corresponding to VO, photoelectric current becomes zero. Is it right? So graph is very simple. Suppose if I use some higher intensity, say I2 and I3. So in that condition I will write, yes, I3 is obviously greater than I2, obviously greater than I1. Say I am using some higher intensity. What happens if you increase higher intensity? Graph you are finding like this. So you are finding graph like this. So it means as the intensity of the incident radiation increases, the saturation current has some higher values. But what about this stopping potential? This stopping potential remains same. And remember, clearly this shows stopping potential is independent of intensity, but this stopping potential is depends upon only two parameters, that is frequency. Okay, even in this condition I have used a fixed frequency, hence I am getting, see, for the all the intensities, say for first condition I1 I have used fixed frequency, so VO. For the second one I3 and I2 I4 of same frequency as I1, as same frequency. This is very important. I2 I3 I am using higher intensity, but condition of frequency is what? Which is same as I1. Frequency is same as I1. So under that condition I am observing VO. Means the stopping potential same even for I1 and I2. Even for I1 and I2 as well as for I3, stopping potential same, because it depends upon frequency and nature of the material of emitter plate. Okay, so once again the observations of photoelectric effect are clearly we can study from the experimental conclusions. This is called saturation current. Here in this study we got two definitions. One is about saturation current, another one is about stopping potential. So this is very important. And remember, so what we can observe that at stopping potential VO, what happens to the kinetic energy? So with maximum kinetic energy the electrons get repelled. And another one point, so all the electrons which are all the electrons from this observation, from this study, what we can write here, what we can conclude means, so at the stopping potential VO, this stopping potential is what? It performs the work on the electrons. And what type of work? To repel the electrons. So therefore the kinetic energy is maximum for the electron corresponding to this VO, and therefore Kmax is equal to EV0. So I can write here one expression, Kmax is equal to EV0. So here is magnitude of charge of electron, VO is this stopping potential. So therefore Kmax is equal to EV0. Okay, so just you remember this equation. And next, about effect of frequency on the photoelectric current, I am going to explain that in my next part lecture. Okay, so please remember all these points and this graphical study, okay, which is very important for exam. Okay, thank you.